Dear students, we are doing interference of light. Actually, I have uploaded 4 videos on interference, and I have explained you how to get maximum minimum intensity. Yesterday, I uploaded a video in which I took 2 sources S1, S2 here. And this was screen, and at point O and P was there. So I told there that if these 2 sources are emitting light in same phase and of same wavelength, so what is the meaning of monochromatic light? Chromatic means color, mono means single. If a source of light, if a source of light emits light of single color, means single color then the source is said to be monochromatic source. Monochromatic source of light. First of all, you must know this thing. Every color has its own wavelength and its own frequency. So, in other words, a monochromatic source emits light. Emit means it gives light from inside, not reflect, of same wavelength. And or same frequency. So, in other words, a monochromatic source emits light of same wavelength or same frequency. Here we have sodium light is supposed to be monochromatic, but that has also 2 wavelengths. Actually, our LED, our incandescent bulb, our fluorescent tube, which were we using, all emits a range of wavelength. LED white light has all wavelength, varying from 4000 angstrom to 7000 angstrom. Sodium light, it is taking as yellow light, sodium light. It has wavelength 5890 angstrom and 5896. So they are close to each other. So sodium light can be, it is not monochromatic, but because wavelength difference is small, sodium light emit wavelength 5890 angstrom and 5896 angstrom, and yellow color supposed to be average yellow color, or sometimes we take the average wavelength 6000. So monochromatic source of light means a source which emits light of same color. is called monochromatic light. But now laser of different colors are available. So now it is very easy to obtain monochromatic light using laser principle. But basically our sodium lamp, even which emit yellow light, it is not exactly monochromatic. We can obtain monochromatic light from laser source. Laser, I have told you, it is a device in which we obtain light amplification by stimulated emission of radiation. I will discuss here also again. Now we come to second point is coherent source. Coherent sources, coherent. Coherent sources. Basically, first of all, a coherent source should be monochromatic. If two monochromatic sources कह रहे हैं इसको sources, क्योंकि more than one होता है ना. If two monochromatic sources emit light in same phase or with a constant phase difference, then the two sources are said to be monochromatic sources. Very important to understand monochromatic sources. The two sources which we have two or more sources which emit light in same phase. Students are very much confused about this word phase. Actually, the equation of progressive wave, I have told you that light waves are electromagnetic in nature. And the equation, it is the electric field which produces sensation of sight on our eye. It is the electric field vector of electromagnetic wave which produces sensation of sight on our eye. I am telling very correct picture, very true picture. Light wave are electromagnetic. Actually, our different books, in most nowadays, in almost all the books, light waves are not treated as electromagnetic wave while teaching interference. They use it electromagnetic wave when they tell polarization of light. So a lot of confusion arises in the mind of the student. So why should we not treat from very early the light wave, electromagnetic wave? The equation of electric field vector of the wave magnitude of electric field is given by I sin 2 pi t upon t minus x upon lambda. And I have told many times that this is phase. So phase of wave or electric field is 2 pi t upon t minus x upon lambda. If I choose x equal to 0 means it has origin. If x equal to 0, then phi will be 2 pi t upon t also. Now how the light is emitted? बहुत जरूरी है समझना, because many times a question is asked why two independent source of light being monochromatic cannot be coherent. उसका समझना है. तो atoms have electrons which can exist in different energy states. Like in hydrogen atom, the energy of electron in any orbit minus 13.6 n star electron volt hydrogen के लिए for hydrogen atom. n equal to 1 रखेंगे तो first energy level. So it is minus 13.6, then it is minus 3.4, then it is minus 1.5 and so on, electron volt. So when atom get energy from somewhere, electron in the ground state take that energy which suits either to go from this to this or this to this or any other higher state. In higher state, electron is unstable state. You may make the note of this in your copy, please. Electron go from lower to higher state, and from there it jumps either from this to this or this to this, and coming back, suppose you have sent electron or electron here, anyway, that is done in laser also. Then it is the sweet choice of electron to come back to the lower energy state. They may go simultaneously to same energy level, but when they return back, they don't come together. And therefore, this T is different for the light emitted by electron when they jump from one higher energy state to lower energy state. ये थोड़ा बात देर से में आती है. आप you have learned in chemistry. I will teach in physics also later while teaching Bohr theory of atom that electron. If I treat Bohr theory, revolve in circular orbit. And in an orbit, electron neither lose gain energy nor gain. It do so when it goes from lower to higher or higher to lower. To go from lower state to higher, electron need energy. And when it goes up, it is unstable and return back to the lower state by emitting extra energy in the form of electromagnetic radiation. Those radiation may be in the ultraviolet region, in the visible region, or even in infrared region. If the wavelength correspond to between 4000 angstrom to 7000 angstrom, then visible light will be produced. But remember that electron jump from higher to lower state at different times. The time interval between them may be a microsecond or nanosecond, but time is there. So waves are emitted at different times, so they differ in phase. And therefore, two independent sources of light, I am telling here, two independent monochromatic sources. Monochromatic sources cannot be coherent. This question has been asked why they cannot be coherent. I think you have got it. It is because electron get excited from lower energy state to higher energy state by taking energy like electric, this LED or any source. When we heat any material, then atom get energy, they go to higher energy state and they return back from to lower energy state at different time. And according to equation, phi equal to 2 pi t upon 2 pi t upon t minus x upon lambda. At any point, t different होगा तो phase different होंगे. Then question arises how to obtain two sources of light which can emit light with constant phase difference or zero phase difference. So actually Thomas Young performed an experiment which is also called as Young's double slit experiment in 1801. I told you earlier also. Now, then how it could be, how can we obtain the two coherent sources? So in Thomas Young, obtained two sources. Actually, he used sodium light. This is sodium lamp. A narrow beam obtained, and he put a screen there before this, and then cut two slits. In simple word, I say the source as here. And if I put here a screen and put two holes here, then these two slits here will be illuminated by this light like this, because wavefront is there. So these two waves, two slits S1, S2 are illuminated by same light. Phase may be changing here, but whatever the change take place, same change take place in S1 and S2, and hence light emitted by the two slits will be coherent. So I think, dear student, you have got my point. Thomas Young, I am telling again, took one source of light, S. A narrow hole was there. And then there is a screen where he made two holes or two narrow slits, long slit also. Then light emitted by this illuminate S1, S2 here. So these S1, S2 act as two sources which emit light in same phase. There was another method, this is called light mirror. Here is the plane mirror. Sodium light, because it is shown to be monochromatic. It plays here. Then light from here gets reflected like this. If we produce them back, we get this image here. So this image of source S will act another imaging source, and light here on the screen will be coming from this as well as this, and therefore they produce interference here. But here on the difference there, because in reflection from rigid surface, there occurs change of phase of pi radian. This is one method of obtaining. Should I repeat it again? I am explaining again. Suppose it is a plane mirror here, and we put here a source of light here. So light fall here as well as on the last corner, get reflected back like this, like this. If we produce them back, we get here the image of this as this. It will be at the same distance from this. So S dash and S, here the screen. The light from two sources fall in common region. The common region is this one only. But the difference is that here at center we will get dark field because light reflected from S dash and S will be exactly out of phase. This is another method. Whatsoever change will take place from in S, the same will take place and S. Similarly, there is another method which is called Fresnel by prism. Two thin prisms are placed like this. I mean, now a source of light is placed here. The light after reference of prism bend toward the base like this, and on producing back they appear to come from this point S1. This prism also make another image and light. During refraction there occur no change of phase. These S1 and S2 will act as two coherent sources here with the common region. आप समझेंगे बाद में इसको, but I have told here how to produce monochromatic coherent sources. The sources of light which emit light in same phase or with constant phase difference are called coherent sources. Actually, I will have to do here derivation of fringe width. So I will use the term monochromatic and coherent sources. Thank you.